my presentation is also in the spirit of LLMs in transportation engineering. And the title is Guiding Persona-Based AI Surveys. Can we replicate personal mobility preferences at scale using LLMs? Basically, what the question is can we generate data that are human-like in the travel context? A quick roadmap. We will present the motivation, the approach, some data sets that we experimented on, and then the results. So in traditional survey methods, you usually set a questionnaire, you spread it, you spend some time spreading it, you spend some time collecting the real responses from real people, and then you spend some money and some time to digitalize and evaluate and get statistics. And we thought that with the rise of LLMs that have the previously mentioned two big benefits. One benefit is the great contextual knowledge, and also the great knowledge of intercorrelations. So it knows how two things could be related more than anything else. We could maybe generate a method that uses LLMs instead of human, or maybe enhancing human respondents. Why we should think of a method? Well, travel surveys are costly, they have declining participation rates, and sometimes people do not want to participate because of privacy concerns. These are some numbers. So, on average, per household, there are these costs nowadays, and similar costs used to be 24 years ago. So, an average national survey would cost tens of millions, or maybe in the tens of millions in euros. An emerging solution could be generating synthetic data. Synthetic data are basically data that could be generated from any algorithm, method, device. And they could promise scalability. So once you have a good method, a good set method, you could scale it by just waiting more or paying a bit more or putting more computational power inside. They are cost efficient. If you think of the tens of millions, let's say if we had the perfect ML model or the perfect model that would predict patterns, once we have this model, the computational power needed to empower it is much less than tens of millions. And also they are always privacy preserved. In this context, there are the traditional methods. So many of you may be familiar with population synthesis, techniques like IVF, iterative proportional fitting, or maybe Bayesian networks, which also take into consideration attribute intercorrelations, or maybe more advanced and recent techniques like machine learning, GANs, etc. And now we come to add the LLMs as a thing to consider. So it's kind of exploratory research. And apart from contextual knowledge and dependency capture, LLMs are also flexible. So everyone remembers COVID-19 and all this pandemic scenario. It would be very difficult at the time to collect data fast enough to train a model and create a complete prediction algorithm. But LLMs could potentially guess well enough human behavior in hypothetical scenarios. So this is one use case. So in case something unexpected happens tomorrow on our planet, maybe LLMs could guide us. And in this context, there is also an interesting research, again in Germany, about how to replicate public opinions using LLMs. So we were not the first people who are trying this. There are some people also with relevant research in this field. First of all, what is an LLM? So for a mathematician, an LLM is a high-dimensional function that approximates a conditional probability distribution. So a mathematician would say, okay, we have a prompt, sequence of words, and then we want to approximate what is the best next sequence of words. For a computer scientist, it's a bit more structured. It's a piece of software. It's an algorithm. It's a neural network, and specifically it's a transformer. It can have layers. It can have billions of parameters like GPT-3, and it's a structured piece of software. For a transportation engineer, it is interesting now. So many would think of an LLM like a human in their pocket, like a human opinion in their pocket. So it's a kind of simulation tool. For a data scientist, it's a huge statistical model with billions of pre-trained examples that predicts the next token. For a survey engineer, it could be useful in two ways. It could be both a hypothetical respondent and an analyst, or a data cleaner, or a data collector, or a data organizer. Well, LLMs are very good at structuring data. And for my grandma, it is like a smart parrot that has everything that is available and can hang out, have conversations, give insightful information. So yes, if we ask about cars, LLMs, of course, have never driven a car, have never been in a car, but they could hypothetically produce human-like behavior because of all this corpus of data that they have learned. And it's important to say that LLMs mostly learn human behavior of stories, and this is in the previous slide, rather than structured equations or data. So in a sense, they are not deterministic models themselves. They learn stories. And here comes our solution, let's say. So can we replicate the personal mobility preferences using these tools? We structured the framework like this. So the main parts are three parts, and of course we have evaluation. The first part is the persona catalog. We first want to have some structured attributes, some structured personas, to identify which are the key personas of interest, and then we want to prompt an LLM. In our case, we used, as in the previous research, pre-trained LLMs. We did not fine-tune anything. But even pre-trained LLMs have contextual and general knowledge about most of the things. And then we calculate how dense these personas are. So maybe some persona of a person being, I don't know, 5 years old and having a PhD is 0.001%. So maybe it's a long tail. We exclude personas that are very rare. And finally, we ask again the LLM the questions of interest and get structured responses. And this is pretty much the methodology abstraction. Of course, then we evaluate. I will mention the metrics. We used prompt engineering. Prompt engineering is the main thing here. We prompt the LLM to become the persona that we want to investigate. And of course, we use guided calibration, which is very important. So if you naively ask an LLM, oh, provide me, I don't know, what will happen in Germany tomorrow, if it has no data, it will provide things that are biased from averages that are global. We will see this in the following slides. We have a formal definition of a persona. It's a combinatorial entity. It's all the combinations of attributes that can occur. And let's stick in this slide for 1 second. For example, we could have attribute groups like age group, education level, main activity, economic status, class, or type. All of these would have various sets. And then we want to calculate every possible iteration through these values. So it's a trivial combinatorial problem. We just multiply, and it's 50,840 personas in our case. So, in a sense, the data set that we produce is not huge. It's within thousands. So, in our previous framework, we want to make some qualitative ablation study. So we want to check which parts are important, which parts are not so important. And then we introduce 4 main things. Maybe I should go to the next slide. Here it's more intuitive. The naive method would just ask from an LLM to generate a mass of population with specific attributes and provide answers to some questions. So this is naive. This is okay, LLM give me everything. There is the structured approach. In the structured approach, we set the demographic distributions of a real population. So we first say, okay, LLM, we are examining a population that has, I don't know, 25% students, 30% elders, etc. and for this population, provide the personas and the responses. We have the guided approach, which is like cheating a bit. It's like also providing to the LLM every possible statistic that we know for this population. This could be, for example, how many people have a car driving license, or maybe how many people are not cannot afford a car, or these kinds of things. And whenever we say persona-based, we mean that we first structure the personas, and then we ask one by one for each persona the LLM. We prompt the LLM one by one to get the responses. We do not naively say, okay, provide whatever the relation is. We ask only for the persona types. We use data from Mobilität in Deutschland 2017 survey for our evaluation, and from OSA in Athens and EDM in Madrid to prove that our method is replicable and repeatable. And we use metrics that are also not only for marginal probabilities, but also for conditional, in the sense that we want to check how well the LLMs could capture the attribute intercorrelation. We'll go through this quickly. So that we can get the results. Well, these are some marginal outputs. This is the mode shares from the previous data sets. In the middle, we can see what happens if we ask an LLM naively. So in the top, it's the real one, right? In the top, we have the real expected percentages. In the middle, we ask LLM provide me whatever you would fill. And you see here that LLM is biased from this storage of human, because it overestimates always the car usage. Maybe a lot of text corpora includes people driving, for example, and then LLM thinks, okay, people drive a lot, so maybe they have cars. And our method fixes this problem because it matches the real distribution much closer. This is the same data. Let's focus on the top left one. This is the marginal mean error, and the orange one is the naive method, and the purple one is our method. And we see that our method has much smaller mean latent error. And also we need to check what happens with intercorrelations. What happens with the LLM capturing intercorrelations, maybe between working preferences and age groups. So we stick to this example. These are the real values from the mid 2017. So if we ask a person how possible it is for you to walk, of course this is not exactly how it was asked. The thing is, they asked for one day, they checked how many people used walking as a main mode of transfer, and then they calculated everything. So people said, I like to walk in everyday life, strongly agree, disagree, strongly disagree, and we have different lines. Using our methods, we made comparisons. And what is interesting here is the bottom right part, which is the guided persona-based AI surveys. What happened in this case is that we created the personas. We also had the tabular data from the mid-2017. People who are familiar with this survey, they will remember how this is structured in the PDF. And then we asked the LLM, okay, provide what is the expected working preference for each persona. Then we calculated all the preferences, and we provided the, again, marginal, but only for this example. And we see here that it closely matches, maybe it matches, anyway, we see here that only 1% it doesn't match exactly, but it follows the structure. So what is what is the result? The result is that if we also have important statistics about the population, and we use this method that treats the LLM as a persona, we can achieve almost accurate replication of populations. So even if some survey maybe does not provide explicit responses to questions of individuals, we could say, okay, we have general statistics, we have a lot of statistics, a lot of questions, and then we use the LLM, okay, to generate a file that has, I don't know, a population of 20,000 people that follow these marginals and conditional probabilities. Of course, this can happen with Bayesian networks as well. And to be honest, when I observed what the LLM is doing internally, it resembles Bayesian networks at some point. But the benefit is that when you need to guess the conditional probabilities, LLMs do very well educated guesses. And for our population study, we saw that, okay, the structure of the population is very important, but the most important characteristic is the personas. So that's why we also have it in our title. Once again, let's remember the strengths of using the LLMs. LLMs are very flexible. This is one thing that I want to point out again in hypothetical scenarios and great cases. So if we need something, let's say, a quick and dirty method of predicting some scenario that we need to predict it in 5 minutes and we don't have enough time to create a full structured ML model or whatever, an LLM, carefully prompted, is a good enough solution maybe. But of course there are a lot of limitations. Prompt tuning is required. If you prompt it in an uncareful way, your data are not going to be good, are not going to be in alignment with what you should expect. So you need to be very careful. When LLM experts say people you should prompt a lot, they do not mean they should write a lot of lines. They mostly mean they should be very accurate. You need to be very detailed and accurate when you prompt. Computational costs, okay. If you generate, let's say, millions of synthetic data, you need to calculate how much does it cost in the sense of tokens, time, energy. This is also one of the great problems of LLMs at this moment. If LLMs continue to rise, as we saw at yesterday's keynote, at some point we need to think of ways to calculate the outputs more efficiently. Data biases and plausibility, we saw this with the car example. Sometimes they overestimate variables based on global attributes, global opinions, or global data that may be not relevant for a specific city, for a specific event. And of course, they're not a full relation yet. Because in all our studies, the good results happened when we had some statistics, we had some results, we had some initial estimation, and then we enhanced the initial estimation using the LLMs. And if I have some time, I have 2 minutes. Everyone can use the LLMs nowadays. They are more accessible by any time in the history. It's basically transformers. 5 years ago, transformers maybe only were used by professionals in data science and computer science. Now, even my grandma could say, okay, I want to implement this idea. And she can create this structured prompt, which is natural language, it's nothing. It's, okay, I want to create a synthetic algorithm in Germany. These are the age groups. I want an educated guess about how many, how German population look like. Keep in mind, this is important, that the attributes of each individual person are correlated. And if we omit this line, this is the naive approach. If we put this line also, this is structured. For example, the household type and the age group are related. If you extend this prompt with more hints, you get better results. And then, of course, we can put it in our favorite LLM, or maybe ChatGPT, and ChatGPT is so kind that after less than a minute, it will produce 10,000 lines, and also you can, my grandma can click, download in Excel, and say, okay, I have generated synthetic population. I'm not sure if she will use it. Some final thoughts. So I come from the field of computer science, and one thing that is interesting to me is whenever people need to create smaller models that are fine-tuned for specific problems, synthetic data or data that are specific to the problem are anyway. And this happens a lot with the APIs. So whenever a new API is open, people want to create a model, a machine learning model that can use this API in a way that is compliant with user's intention. This is very difficult for models like for Llama open models, the small models, 8 billion parameters. But it's not difficult for, let's say, closed models. Open and closed model means if a model is open, anyone can see the variables, the parameters, everything. Everyone can fine-tune it, everyone can dive into how it works. It doesn't mean that it is explainable, but we can see how it works. If a model is closed source, like the GPT or like commercial models, you get the outputs, but you're not able to fine-tune it always. Maybe you need to pay the provider. So one idea, and this is something you can keep from this talk, is that you can use a powerful closed source model. You can generate your structured training data, and then using this training data, you can fine-tune a cheap model, an open source model. And then the outcome, the result, is a pretty strong model. So it's pretty much the best thing you can do. And what would be a goal in this direction? Maybe if we have this computational power and if we had a solid methodology for replicating populations, of course this is the goal of it, but I just pointed it out here again. Then due to these advancements, we would have cheap and reliable synthetic data whenever we want. Okay, thank you very much. Please go ahead. Let's go bottom.
So just one question in the last part we did. So how do you prevent hallucination? How do you prevent hallucination? Because the use of large language models
Exactly.
This
is a very good point.
prompting is not enough.
Prompting is not enough.
No.
Of course, it's not enough. But at the end of the prompting, the more intercorrelations you explicitly
I know. The biggest problem is another one is that for our project I'm testing different large language models, and sometimes you need to put an expensive model in order for him to stick to what you say.
Yeah.
Even though you can like put all the guardrails that you want, all the prompting, caps lock, it, whatever you want. Sometimes it
This is true. This is a very good point. Usually, so I did not implement it, but the usual solution would be to create a framework.
Another point is that I usually recommend is if you want to do something like this, you need to be like, at least what I do is like I test how the prompt will look on the large language model to then see, okay, am I giving it enough information? For example, you should put like the tables, like table data information. And also another point is yes, still related to hallucination is okay, so I want to use like a large language model to generate the synthetic data. And then again, like you cannot prevent hallucination. It's like, oh, I just inflate the data with fake data, and then what I'm seeing is nothing. So the variation part.
This is a very good point. So from my experience in this project, we tried naive methods, and then it set some inputs. So you see here. This is from structure, but there were some inputs that were like, okay, 50 to 59 years old, education, I don't know, main activity, student, or which is very rare in the population, or economic status type, and household type. I don't know, maybe it's not a good example, maybe 5 to 13 years old, and be a pensioner. These kind of hallucinations happened in the approach because we did not explicitly ask it to stick to to focus on the intercorrelations. I am aware of this point. There is a very nice project called GraphRag. Yes. Many of you may be familiar with RAG approaches for LLMs. RAG is retrieval augmented generation. So, for example, if here my grandma also inputted PDF, this is RAG in a few words. And if you put a GraphRag is a pretty new thing from Microsoft. It was out January 24, I think. And what we did in this approach is they took data, but instead of building just a RAG, so that the typical RAG system focuses on a specific text corpus and searches for similar words with a prompt and then takes hints from it. The GraphRag system structures the information first into a graph that has intercorrelations with elements. So this system, I did not test it yet. This is one of the first words that I'm going to do, but this system seems to me promising.
So one final note, I always want to point out that these large language models that we use are profit oriented. So the only benefit from us of recounting the every prompt that we make makes them more money. So
this is a good point.
We can discuss later.
Yeah, sure. Please.
Yeah, thanks for the presentation. I thought it was interesting. I am wondering about macro. My understanding from large language models, they good for predicting the next sequences of words. So what then for this particular problem, for predicting the mobility preferences of people, wouldn't you want to use some other model which has nothing to do with language itself, but more like a classification, like you could model the classification problem, I guess. You could also use transformers. What did you think about this?
This is a good point. I thought about this. One reason why I stuck with LLMs at the first point is because in some surveys, maybe not in MEET, in the example that I have here, but in many surveys we have open-ended questions. You have questions, so what do you feel about using the class? And then the respondent writes a text. And in these cases, LLMs are pretty good at capturing some the intention of the answer. So restructuring the open-ended answer into more structured format. Also classification models are okay for most of the cases. Yeah, maybe I should take it. Thank you. Please.
First of all, and I didn't get it, but you actually use a ChatGPT form to make all destination elements. Also, pure LLM.
Also with the framework. So it's both prompting from the interface of ChatGPT, but also with the OpenAI API key. But
for asking for the LLM package, you use ChatGPT or you use because it's such a there are multiple models, there's not just LLMs. The reason why we make citation that's okay. Can I ask you the process of the data? Because I think you do some time clinical
no, I do not do anything. Everything
so you have some data, you have it. You ask ChatGPT or the LLM, the framework, to make like 10,000 people of this certain zone. You have the results, you just compare it with the data that you have. Is that it? Am I correct?
Partially. So it's
Because
similar to the RAG framework.
there is a little problem. If your data is not super new, maybe the ChatGPT or the training can be trained already over it. So if you ask a city that already has
This is
so this can be a product, of course, to demonstrate it. I don't know, because we cannot ask OpenAI to I can see which data you have.
This is actually this was a consideration from my side as well. And I thought that if I asked the naive approach very carefully on which data I wanted to host, I would find the exact values. So my initial experience, I tried specifically asking for what the MEET 2017 survey was. But unfortunately, so maybe this is because of the spirit of MEET 2017. reason why was the PDF of the statistics that was provided with the mid-2017. Because also when I tried directly giving this PDF and asking, okay, restructure it into an Excel or provide me this statistic, it could not read the PDF correctly, which was.
On the other side, I would say it's like the user point of view.
Yeah, of course, I totally get your point.
Once again, it's a black box, so
It's a black box.
you never know
Yeah.
what's happening. But thank you, and I can go again.
Also, thank you. Please.
Yeah, so just, I think it's super interesting work, and it seems like it's very good at replicating the patterns observed in the real data, but of course it's not real data. It's synthetic data, and I get that there's value in having synthetic population, but kind of what caution ought we to take in drawing meaningful conclusions from synthetic data? What are the limits to that? But presumably we still need the household travel surveys in order to learn something new. So what nature role does this do, and what sort of words of caution would you offer? So if any of us here listening who have some boss who's, oh, well, why don't we just ask ChatGPT to tell us how to plan our transportation system, what do we say to that?
This is a very good point. Yeah, to begin with, we could not substitute the real data. So your point is we need the real data to begin. The point is that if we had the LLM and the evaluation part, what you're mentioning is a trouble. There is a framework from Ligieris, which framework, maybe you're familiar, I'm not sure. It's there is some research that they propose a framework that checks how well synthetic data are based on real data. This is an active area of research. I am not very familiar with how we should proceed on this in order to convince our bosses or general audience. Yeah, but it's part of future work. It's very good point. Thank you.
Maybe a suggestion, because you brought the next week.
Yes,
maybe
please.
a good idea to continue discussion.
You can also ask the question.
But
Do you mind if you?
I can provide, yeah, I mean,